Hiya, so let's go through the answers to some of these. I'm going to work through the worked example first of all, and then you can pause it if you need to before you go on to see how the rest work. So in this first one, I'm looking to identify groups of hydrogens that are the same as each other or that are different to each other. So this CH3 group on the end here, that's unique. None of the other hydrogens are the same as that. Hopefully you've got your worksheet in front of you and you can see a bit more clearly than this. I'll draw mine a bit bigger. We've got that CH2 group there. Those hydrogens are different to the hydrogens on that terminal carbon. They're just going to behave differently. Sorry, my computer's beeping. And then these two here are basically going to behave as if they're the same as each other because they're both methyl groups that are attached to a carbon that has no other hydrogens attached to it. So they behave the same. So that means here I have three different environments. I've got three different colours identifying my groups of hydrogens. And if I look at those hydrogens and look at how many there are in each environment, I have 3 and 2 and 6. I can't simplify those numbers any further, so that's why the relative intensity of my signals becomes 3, 2, 6. So if you haven't had a go at some of the others, or that wasn't quite clear, then pause here and have a go at some more of the examples. I'm going to pause, I'm going to draw out my structures, and then I'll start explaining them and we'll look at the different environments. Okay, so I'll be back in just a moment with all those structures drawn out. So as if by magic, here they all are. So just to clarify, if I have a different number of hydrogens, then it's automatically a different environment. I can't have 2 hydrogens in the same environment as something else with 3 hydrogens. So let's have a look here. Remember, we're looking for symmetry, and I'm looking for ideas about rotations as well, how things are behaving. So in this one here, I've got 2 hydrogens in that group, and that environment rather, and then this carbon has no hydrogens attached to it. So therefore, because they're both CH3 groups, they are both the same environment. So that means here I'm expecting to see 2 signals. And if I look at my number of each signals, I have 2 in that environment and 6 in that environment, but that can be simplified. So my 2 to 6 becomes 1 to 3. So propene. Just glancing at this, I can see that I have 3 lots of hydrogens with a different number of hydrogens in each environment. So that means that's going to be 1, that's going to be 2, and that's going to be 3. So because there's 3 different numbers of hydrogens, I have 3 environments. And just looking at the number of each of those hydrogens that's present, they're going to be in the ratio 2 to 1 to 3. Okay, I can't simplify that any further. Remember, if you're starting to get to grips with this or you can see a mistake you've made, pause it and have another go for yourself. Okay, chloropropane. This is a symmetrical molecule. So that means that those hydrogens are the same as those hydrogens because there's a mirror symmetry through the centre of the molecule here. And this one on its own is going to behave slightly differently. So that's going to give me 2 signals, and I'm going to have a ratio of 6 to 1. 3 hydrogens here, 3 hydrogens here, and just 1 in that central environment. Next one, hopefully you've spotted as well that there's some mirror symmetry through this midline here. So then my CH3 groups here and here are going to otherwise be identical. So that means I have just 1 environment, so I'm only going to see 1 signal, and relative intensity becomes slightly less important because there's only 1 signal there anyway. So it doesn't really make sense to write 6, you can leave it blank. Okay, Remember, we're looking at the protons here, not just at what they're attached to. But I have one environment for the 2 hydrogens in the amine group, and I have one environment for the 3 hydrogens in the methyl group. So I'm going to get 2 signals, and they are in relative intensity of 3 to 2. Okay, nice big molecule here. So whilst I do have that carbonyl in the middle, and I've got a CH2, CH3, CH2, CH3, excuse me, these are not going to behave as if they are truly symmetrical. The fact that we've got these different oxygen groups means that they're not going to behave in exactly the same way. Okay, we're going to get a little bit of difference in basically these hydrogens looking at what's their neighbouring atom. These hydrogens are in the middle of a carbon chain. These hydrogens are in kind of an ethyl group that's attached to an oxygen, so they don't behave the same way. So that means I'm going to have 1, 2, 3. Need to find another colour pen quickly. I'm going to have 4 different environments of hydrogens here. And they're in the ratio 3 to 2 to 2 to 3. Okay, I can't simplify that any further. Okay, next one. Again, remembering the rules from earlier on, I've got 3 different numbers of hydrogens. So that means they're all going to sit in 3 completely separate environments. So I'm going to have 3 peaks, and just copying the numbers of hydrogens present in the ratio 2 to 1 to 3. Nearly there, you're doing well with this. Have a break after you've gone through them. So I've got my 3 hydrogens here that are attached to a carbon with 2 hydrogens, so that's 2 different environments. And then no hydrogens on this carbon, no hydrogens on this oxygen. And look, these 3 methyl groups, because this carbon has no hydrogens on it, they are all one environment. They're all going to behave the same. So in terms of numbers of signals, I'm going to have 3 signals, 1 for each of those environments. And those are in the ratio 3 to 2 to 9. So I'm expecting in this NMR spectrum a massive peak where all of these hydrogens exist compared to the size of those other 2 peaks. Last one. Look, we've got a symmetrical molecule again here. There's a double bond through the middle. So that means that this hydrogen is going to be the same as this hydrogen, and that these 3 are the same as these 3. So that means I only have 2 environments, so I'm only going to get 2 signals. And the relative intensity, well, I've got 6 in my pink compared to 2 in my blue, and that simplifies as relative intensity of 3 to 1. We'll have a chance to practice this as we look at some more examples, but well done. I'm going to pick the PowerPoint up and the next bit of explanation before we then come back to finishing off this sheet. Good work.